Alright, so this video is meant to follow along the review of solving quadratic equations by factoring and using the quadratic formula. It should be video number 1 in unit number 3, lesson number 6. Our second video here will go through examples 2 and 3 from chapter 3.5, as well as talk about a few additional details, including exact form, or what your textbook calls simplest radical form. Our learning goals: quadratic equations in the form ax squared plus by plus c equals 0 can be solved, meaning the x-intercepts can be determined algebraically or graphically. The x-intercepts, also called roots or zeros, can be solved for by factoring, using the quadratic formula, and by graphing. Our success criteria: solve quadratic equations by factoring and by the quadratic formula. And your practice comes from chapter 3.5, numbers 1 to 6, 8, 10, 12, and 14. So here we see example number 2 from chapter 3.5, solving a problem involving a quadratic equation. A water balloon is catapulted into the air from the top of a building. The height, h at t, in meters, of the balloon after t seconds is h at t is equal to negative 5t squared plus 30t plus 10. We're asked to determine what are the domain and range of this function, and when will the balloon reach a height of 30 meters. So before we even start, I just want to quickly sketch out what's happening here. So we've got a building, and we're going to fire our water balloon off of it, and it's going to come back down. So we can see that this is roughly parabolic, but that we start higher than 0 because the catapult is on top of the building. We're going to fire up, we'll hit a maximum value here, and then we'll hit an x-intercept over here. As such, before we even get into this question, we should be able to identify that we have a vertex, we have a single x-intercept that is relevant, and we would have another x-intercept that would exist graphically but would not be part of the actual solution because it would happen in the past. So your textbook goes about part A in a way that I wouldn't necessarily recommend, but you're welcome to use this method if you choose to. So for determining the domain and range, we're going to need to know the location of the two x-intercepts as well as the vertex. We need the two x-intercepts because we're going to go about solving for an x-intercept. We need to know what both values are in order to know which one counts and which one would be discounted. And that would be the end point of the path of our parabola, namely what we see over here on our sketch. We know that we're going to start at 0 seconds because that's when we're firing it from the catapult. So the second x-intercept will not be used for our domain. Now the part that I don't necessarily agree with is that they complete the square in order to find the y value of the vertex. I think that that's more work than necessary, but you're welcome to do that if you're comfortable with it. I'm going to detail a different method that we can use because we are using the quadratic formula to get our x-intercepts. So we're going to skip over the first piece and go right down to where we start looking for our two x-intercepts. So we set up our equation and we set the h at t to 0. And the reason we set h at t to 0 is at the two x-intercepts, the height is 0 meters. So what we're doing is solving for t when we have a height of 0 meters. Here we go about using a complete the square style solution as opposed to actually plugging into the quadratic formula. So again, not necessarily what I would recommend. So I'm going to just cross this out here, okay? And we're going to go about actually using standard form and plugging it into the quadratic formula in order to get our two x-intercepts. So here we see our equation. H at t is negative 5t squared plus 30t plus 10. And we're going to be using the quadratic formula where x can be determined by negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So we're going to plug in our a, b, and c values. I'm just going to color code them here. So whenever we see an a here, we're using that -5. Whenever we see that b value, we're using 30. And whenever we see the c value here, we're going to be using 10. Meaning, when we punch this all in, we're going to see that x is equal to -30 plus or minus the square root of 30 squared minus 4 times -5 times 10, extending that. And we're going to divide all this by 2 times -5. A few things to note. I have had a few cases where people don't extend this division across the entire numerator. Everything needs to be divided by 2a. Okay? What I often will see is people forgetting to have the -b term being divided. Just make sure that you're watching for that. And so we're going to do 30 squared minus 4 times -5 times 10 to give us 1100 underneath that root sign, and we'll simplify 2 times -5 to give us -10 as our denominator. So from here, we're going to take the root of 1100. We'll see x is equal to -30 plus or minus 33.17, all divided by -10. And from here, we will determine our 2x-intercepts by simplifying for the plus 33.17 and the minus 33.17. And so as we evaluate for both of those, we will get x equals -0.32 seconds and x is equal to 6.32 seconds. But we know that we can't have a negative time, which means that this root will not be counted, and we will have x equal to 6.32 seconds as the time where the water balloon will hit the ground. As I had mentioned before, I wasn't a fan of the textbook using completing the square to get the vertex, and the reason for that is you're already going to go and find your 2x-intercepts, so we can find the axis of symmetry just by taking our 2x-intercepts of 6.32 and -0.32, adding them together and dividing by 2. If we were to do that, then we're going to get h is equal to 3. So that means that the vertex will occur at 3 seconds. From here, we sub in h at 3 seconds is going to be -5 times 3 squared plus 30 times 3 plus 10. And we're going to be able to evaluate for that, getting an answer of 55 meters. And so what we've done here is identified our maximum height of 55 meters for our range, as well as our maximum time for the flight of the water balloon, which is 6.32 seconds. And we will use both of those in order to establish our domain and range. So for our domain, we know that we're dealing with time as our independent variable. So time is an element of the real number systems. We know that we can't have a time less than 0 seconds, so 0 is less than or equal to t, which is less than or equal to our x-intercept, which is 6.32. There's our domain. For our range, we're looking at the height at a given time being an element of the real number system. And we know that that height has a minimum value of 0 because you can't go into the ground here, and that h at t has a maximum of 55 meters based on the vertex of the parabola. And so there we have our domain and our range, and it was all done through using the quadratic formula as opposed to completing the square and then having to go and find your x-intercepts with another method. I just think that that's more efficient. It's up to you, whatever method you want to use, but that's the way that I would recommend approaching a question like this. I want to just go back to the start of our quadratic formula in order to use it as an example for exact form, or what your textbook calls simplest radical form. So in this case, we would continue along with x being equal to negative 30 plus or minus a root, but what we're going to do is split up the root of 1100 to the root of 11 multiplied by the root of 100. We'll divide all that by negative 10. So what this allows us to do is simplify our roots and maintain exact answers, ones that are not impacted by any decimals or rounding. So we're going to see negative 30 plus or minus 10 times the root of 11, all divided by negative 10. What I've done here is evaluated for the perfect square, and so instead of having the root of 100, I've simplified it down to 10. But because the root of 11 is not a perfect square, I keep it as a root. This allows me to ensure accuracy is maintained. That's as far as I want to go with working through exact form. You're going to run into some practice questions, so when you go through those, after you arrive at this stage, you're then going to have to go and simplify into your two exact roots, just like before, noting that you're going to maintain your root that has been simplified, and you're not going to evaluate for it. Alright, so give those practice questions a shot, and if you have any difficulty with those ones, just shoot me an email. Moving on, we're going to quickly look at question B from example 2, which asks, when will the balloon reach a height of 30 meters? And so what's happening here is we have our building, and we're catapulting the balloon off of the building, and it comes and hits the ground. We know that it has a vertex at 3 seconds with a height of 55 meters, and we know that we're going to hit the ground at 6.32 seconds. So what we're asking here is, when will we have a height greater than 30 meters? And really, all that we're doing is finding these x-intercepts here as if this horizontal line were our new baseline. But we can't actually do that without manipulating the equation. So what we do is we sub in 30 as our h of t. And then we're going to use algebra in order to bring that 30 over to the other side. So we're going to do 10 minus 30, which will give us our negative 20. That's all the work you have to do that would be different from solving for your x-intercepts. We then plug into the quadratic formula like normal and evaluate to get 2 times. We're going to see that at 0.764 seconds and at 5.236 seconds, we're going to achieve a height of exactly 30 meters. Every time between those two values will be greater than 30 meters, and every time less than or greater than would be a height lower than 30 meters. Example number 3 is a word problem using an area model. You may remember seeing questions like this from grade 10, but if not, we're going to go through it in detail together. Okay? So we're told that a factory is to be built on a lot that measures 80 meters by 60 meters. A lawn of uniform width equal to the area of the factory must surround it. How wide is the strip of lawn, and what are the dimensions of the factory? So a lot going on there. We're told the area of the entire lot. we're told that we're going to have a lawn of uniform width, and that the lawn and the factory are going to take up the same area. So a fair bit happening there. Let's start by working with the original diagram. Alright, so what happened here was we said let the width of the lawn be x meters, where that x meters represents the uniform strip all the way around. So we can see that we've got 4 separate dimensions of x meters surrounding the factory. We've got 2 in the width and we've got 2 in the length. So if the entire width is 80 meters, then the width of the factory would be 80 meters minus 2x, which is what we see detailed here. Similarly, if the entire length of the lot is 60 meters and we have 2 unknown strips of grass, then the length of the factory is the 60 meters minus the 2 unknown strips of grass. Now this gives us a lot of information before we even start trying to model things. We can find the area of the lot, which we know is going to be 80 times 60, and that's going to give us an area of 4,800 square meters. Additionally, we can get the area of the factory, and we can do that by multiplying 80 minus 2x times 60 minus 2x. When we expand that out, I'm just going to put the final simplified expression here, but we're going to get 4,800 minus 280x minus, or correction, plus 4x squared. Okay, so there is our simplified area of the factory. Now we know that the area of the factory is equal to the area of the grass. That means that we can subtract the area of the factory from the area of the lot in order to get the area of the grass. And so just to reiterate, we know that the area of the lot is 4,800 square meters. The area of the factory is 4,800 minus 280x plus 4x squared. And in order to get the area of the lawn, we're going to subtract the area of the factory from the area of the lot. So what that means for us is we will take 4,800 minus 4,800 minus 280x plus 4x squared, and this will cause us to distribute that negative into all 3 terms. So we'll get 4,800 minus 4,800, which is 0. We'll get negative 1 times negative 280x, so 280x. And we'll get negative 1 times 4x squared, so minus 4x squared. And now we have an expression for the area of the lot, the area of the factory, and the area of the lawn. We know that the area of the lawn is equal to the area of the factory. And because of this, we're going to substitute both of the 2 expressions we have in and create an equation that models the equal areas. Alright, so here we have the expression of the lawn on the left-hand side and the expression of the factory on the right-hand side. What we are going to do is bring all of our terms to one side so that we have a quadratic equation in standard form. In order to do that, we're going to subtract 280x and we're going to add 4x squared to both sides of the equation. and so that allows us to cancel and cancel. 0 would be equal to 4,800 minus 560x plus 8x squared. If you're following along with your textbook, they brought the factory over instead, so the terms are all reversed in terms of their signs, but it's still going to work out the exact same way for us. Now, in this question, your textbook factors, and there's nothing wrong with factoring. You could have also used the quadratic equation here. Doesn't make a difference. So we start by common factoring out the 8 from all three terms, giving us 8 times 600 minus 70x plus x squared. You could rewrite this so that you had x squared minus 70x plus 600. Again, not going to make any overall impact. But now we need to factor our simple trinomial. So we need a product of 600 and a sum of negative 70. This will give us factors of negative 10 and negative 60. Negative 10 times negative 60 is 600. Negative 10 plus negative 60 is 70. So here we have our factored form. From here, we can get our two x-intercepts by setting 0 equal to x minus 10. So that means 10 would equal x. And setting 0 equal to x minus 60. So that would mean 60 is equal to x. Now, one issue here is if we were to take a strip of grass that were 60 meters on either side of the factory, it would end up being too wide for our width and too long for our length. You would need at least 120 meters for both of the dimensions of the lot. That means that we cannot use the dimension of 60 meters. Instead, we only can accept 10 meters as the width of the strip of grass. And so now that we've found that the strip of grass is 10 meters on each side, we still need to complete the actual question. If you recall, we are asked what are the dimensions of the factory as well as the strip of the lawn. So to finish this question off, we will take our 80 minus 2x and say that that is 80 minus 20, which gives us 60 meters. And then likewise we will do 60 minus 2x, which is 60 minus 20, giving us 40 meters. Therefore, the factory's dimensions are going to be 60 meters by 40 meters. Alright, so that's everything for today. I'm hoping that that was mostly review. The work with exact form or simplified radical form might be a bit new for you, but it's just combining using the quadratic formula and simplifying roots from earlier on in this unit. Like I had said, if any of this gives you any trouble, just shoot me an email. You know my email by now, but if you need it, it's mayatt@hwdsb.on.ca. Alright, so that's going to be it. I hope everyone has a good long weekend. Take care of yourselves, and we'll have another lesson ready to go for next week. Bye for now.